I'll do my best to describe this project called Raptor, and at the end I will give you a demo as well. Before I start, I just want to give a shout out to my team. I'm on Joel Meyer's automation and tooling team, and I just want to say thanks to Joel and a whole bunch of people on my team, Ahal, BC, G Brown, I Golden, and a whole bunch of other people who have contributed to Raptor. It's definitely been a group effort, and I'm just appreciate for all the help. So I'll get started. What is Raptor? It's probably best if I start and just talk about an existing framework called Talos, and a bunch of you have probably heard of Talos, I'm sure. Talos is a Firefox desktop performance framework, and some of the tests that Talos do are page load tests and benchmark tests. A page load test is exactly as it sounds. It basically loads a web page and takes a performance measurement. A benchmark test is like a standard web benchmark, such as speedometer, which is a third-party benchmark test, and it provides a score. Talos is awesome. We've had it for a number of years, and we're still going to keep Talos, but it is somewhat limited in some ways. For example, it is limited to Firefox, and also for page load type tests, Talos is only able to record one type of measurement or one value on each single page load. So that was some of the reasons we decided to move ahead and develop sort of the next generation Talos, and that is Raptor. Raptor currently supports two types of tests, a page load test and benchmark test. As I mentioned, page load loads a page, measures a value. Benchmark is a third-party benchmark test. Raptor is designed as a web browser extension using standard web extension APIs. Therefore, it's cross-browser compatible. For page load tests, Raptor supports multiple measurements per single page load. So even though we only load the page once, we're able to grab a bunch of different values from that single page load. For example, we measure first non-blank paint, and we can also measure, well, we can basically measure anything that we can trap an event for or use an API to get a value for. Another type of measurement that Raptor is capable of is a hero element, and I'll talk a little bit more about those a bit later. I just want to point out Raptor is currently running on Mozilla Central as Tier 2. If you look on TreeHerder and search for Raptor, you will see it, and we have Raptor tests running there on both Firefox and Google Chromium. So how does Raptor work? To run Raptor locally, you can invoke it using mock Raptor test. And to run and try, you can use mock try fuzzy and just search for the Raptor jobs. Later on, I'll post into the Integrity channel a link to the Raptor wiki so you can get more specifics. So I'll just generally walk through how Raptor works when it runs a page load test. So to do a page load test, you basically want to load a page and measure some kind of performance for that page load. When you're doing a page load test, you don't want to measure a live site, at least we don't want to in this case, because that leaves a bunch of options. The net could be down, the page could be down, the page can change, stuff like that. So what we do is we use a tool called Midden Proxy. Midden Proxy is a tool that allows us to record a web page and save it as an archive, and then we can later play that archive back, and then Firefox will just access that page through a proxy. So I mentioned before about hero elements. So hero elements are basically a method to allow us to measure when a specific element on a web page has been displayed. So what we can do is, after we make a recording of a page as a Midden Proxy archive, then we can insert into that recording a hero element somewhere where we deem important to measure. For instance, in the Google search, you might want to put a hero element on the first search result that comes up in the search, so that just something to measure, say, hey, this is how long it took to get to that search result. It's a bit tricky inserting hero elements, but it's kind of cool that it's possible to do that. But again, we can measure all kinds of stuff with Raptor, anything that has an event or an API. Currently, the test that we have for Raptor page load, the test suite is called TP6, and we measure page loads for Facebook, and it's actually a logged in Facebook page because Mint Proxy supports HTTPS. We measure an Amazon search. We measure loading the YouTube homepage. We measure a search in Google. Also, we have a new suite recently added called GDocs, and it's for Google Documents. So we measure a Google document load, a Google Sheet, a spreadsheet, and a Google slide. So I think the best way to kind of give a general overview of the architecture of Raptor is just to kind of explain what happens when you run a test. And again, I'll give a demo a bit later. And feel free, if you want any more details, just to ping me separately later on. And I'll put a link for the source code as well. So to invoke a Raptor page load test, when we're running this locally, you use mock Raptor test command line. For example, you can do mock Raptor test --test Raptor -TP6. And Raptor will automatically download the Mint Proxy recorded archives that are needed for that particular test. Mint Proxy tool is automatically installed. And since it supports HTTPS, we have to import the CI certificate from Mint Proxy into Firefox, and that's done automatically. Then we create a new browser profile because we have to use certain preferences. For example, to measure first non-blank paint, we have to turn on the times non-blank paint profile. And as I mentioned before, Raptor is based on a browser web extension. So the browser extension is loaded into the profile. Next, Firefox would start up and it points to the profile. And so the browser extension is loaded. The extension is the main runner of the framework. So as soon as the browser starts up, the extension takes over. So one difficulty we ran into is a web extension, you're somewhat limited because you just want to use standard APIs, and for good reason, you're locked down in a lot of ways. So we needed a way for the web extension to be able to talk to the browser harness, the Raptor harness, or in the outside world. So we decided to use a server we call the Raptor control server. So this is kind of like the glue in between the web extension and the test harness. So when the browser starts up, the Raptor web extension asks the control server, it says, hey, tell me the information I need to know. What test am I running? What's the location of the source? And what am I supposed to measure? How many cycles am I running? Stuff like that. So once it has all the information, the web extension opens a new tab, browses to that test site, and then the page loads, and the web extension basically captures the performance measurements, whatever we're measuring, and it's repeated for X number of page cycles. We use 25 page cycles right now for a page load test. Once all the cycles are done and all the measurements from each page cycle are gathered, the web extension reports the results to the Raptor control server. The Raptor control server takes those results and formats them so that we can dump them into Perf-Herder. I'm sure you've seen Perf-Herder. And then Perf-Herder picks up these results and we can use them in our automated regression alerting CI and toolchain. Once the results are dumped out, the web extension sends a message back to the control server saying, okay, we're finished. You can kill the browser. Control server shuts down the browser. The Mint Proxy tool, the playback tool, is stopped and the control server is shut down. The similar flow for a benchmark test, it's very similar. You just change the test name on the command line. Now, benchmark tests are a little bit different because they're a third-party source code for those. So there's different ways, there's different locations of these benchmarks. You've probably seen them in Mozilla Central, third party, WebKit, performance tools, or performance tests. There's some there. We also use a perf automation GitHub repo for some benchmarks that are not in tree, because some of these benchmarks are really huge. So when you run a Raptor benchmark locally, we need to get this source. So we either grab it from the in tree, or we clone, we get it from the GitHub repo, from our repo. In production, we actually use a fetch task thanks to Ahal, and we use basically, it's a task cluster job that's running, and it has already grabbed the benchmark source for us, and so we just go to that task and grab the artifact as we need it. So once we have the source, once Raptor has the benchmark source, we start a local web server and serve out the benchmark. And then it's the same flow. We create a new browser profile, install the Raptor web extension into the profile, start up the browser extension takes over, opens a new tab, browses to the benchmark source URL, and the benchmark runs. Now it's a little differently in this case. We have to have a little bit of minor code added to the benchmarks, and that once a benchmark has finished each cycle, we have it report back using window.post, just saying I'm finished and here's the results. The Raptor web extension can grab the results directly from the benchmark, and then does the same thing. Formats the results for perf header, dumps it out to the console, the perf header picks it up in production, and the web extension tells the control server we're done. Control server shuts down the browser, and the control server shut down. I'm just going to post this link for you in IRC integrity channel, in the integrity channel. This is the Raptor wiki, and I want to post a link to the source as well in case you're interested. And that includes the source for the web extension. You'll see everything in there. Oh yeah, I just want to mention a little bit of future work. Right now, we are working hard to add Android GeckoView support to Raptor. The ultimate goal is to run like third-party benchmarks on GeckoView on physical devices. So BC and G Brown and myself and Jay Mar, a bunch of people, and the GeckoView team are working on this. It's kind of exciting. Also in the future, we're going to add DOM content loaded as another measurement value to page load test. There's been requests for that. And one thing that we're going to look into at some point down the road is the possibility of having in-page navigation in case we want to measure, say you have a huge Google document and you're on the first page and you want to scroll to the last page and then measure how long that took. Okay, so I'm just going to give you a quick demo here. So I'm going to try to share out my screen. Hopefully this will work. Okay, just give me 1 second. Okay, this should work. Okay, can you see my screen okay?
I can see it.
Okay, awesome,
Yep.
Thank you. Great, thanks. Okay, so what you're looking at right now is an INI file, and Raptor uses INI files for test definitions. So you can look at these in more detail later if you like, but this is just an example of the INI file for the style bench benchmark. This is the typo, that should be style bench, sorry. Okay, so basically these are just settings that Raptor will pick up. So what type of test are we running? In this case, it's a benchmark. The test URL is just what it sounds like. That's where the source of the benchmark will be located, which is served out locally, and obviously the port is subbed in later. How many page cycles do we run? Normally we run 5 page cycles. at least. It depends on the benchmark, actually. Depends how long they take. I've just set this one to 1, so it'll be shorter when I show it to you. Page timeout, we need the Raptor web extension to time out if the test obviously doesn't fail for some reason. So you can set your timeout value here, milliseconds obviously. Unit, you can have, in this particular case, this benchmark has a score. In different types of tests, it could be milliseconds or some other unit. We need a way to tell our like our perf herder, our regression alerting CI system, if the score, if it's better to be the lower score or not. In this particular benchmark, it's a score, so a higher score is actually better. And the alerting threshold, again, this is something that we use in perf herder in our automated CI system that looks for automated performance regressions over time. And you can set a threshold here for when you want to be alerted. Okay, just another example of another. This one's a little more. There's a little more to it, and this is for a page load test, TP6, and it's basically a lot of the same settings. But you'll notice in here, we're using a playback tool that I talked about, min and proxy. So we have to specify, hey, we want to play these pages back using min and proxy. There's manifest files that say, because we use tools to grab the min and proxy recordings. So we need to know how to get those. We need to know the name of the manifest. And then for each individual test, for example, TP6 Amazon, when we're running TP6 Amazon page load test on Firefox, these are just the settings that apply there. So we're saying we want to play back. This is the min and proxy recording name. What's most important here is this line here, measure, and that's where you define what we want to actually measure in a page load test. Because a page load test, we can measure all kinds of different things, right? So right now, we're saying for this particular one, let's measure first non-blank paint and a hero element. And then we have further definition of hero because you might have multiple hero elements in one page that you want to measure. In Amazon, this particular example, we measure first non-blank paint, which is a general page load value, and we measure a hero element, which is located in the first element of the Amazon search. And again, you can look at these later. These are all the definitions if you're running which test you're running. Okay, so I'm just going to show you one of the benchmarks. So it's a really simple to run Raptor locally, mock Raptor test, --test, and the name of the test. This is obviously in Central, so you don't have to specify the browser. It will just run your local nightly build. Okay, so I'll just start that up. So Raptor's already created a new profile. It's already installed the web extension into that profile. It has grabbed the source of the benchmark. This is style bench, and it has served out the source locally. And now it has started the browser, and the browser extension has taken over. Right now we have a 30-second pause because we want the browser to settle. Sorry, I could have reduced that for this demo, but just wait for a couple of seconds. And there you go. You can see this benchmark is starting. And it is supposed to look like that, so don't worry, it looks a little bit different. And I do not know much about the benchmarks, to be honest, like what they actually measure, but you can Google style bench if you want to learn more about this particular benchmark and what it's measuring. And you can see this is logging output from the control server, and the control server has basically said, yeah, the web extension has told me I'm about to run one page cycle of this URL, and page cycle has begun. And so we'll just let this finish up. It does take another minute or so. So basically at this point, the web extension is sitting there waiting for the benchmark to finish, and it's waiting to receive a message from the benchmark saying, hey, I'm finished, and here's the results. And the web extension knows how many page cycles to repeat. In this case, we set it to 1. So once it gets those results, we'll see it post the results to the control server and shut down the browser. There we go. Oh, and of course, something happened here. We may have got a timeout. It took a bit longer than expected. Anyway. Okay, and I just want to quickly show you the same thing, but with Google Chrome. So when you're running Raptor against Google Chrome, I just wanted to mention that right now we just support page load types and tests. Or sorry, we just support benchmark tests with Google Chrome because page load types of tests, as I mentioned, requires work with midden proxy, which requires setting up a proxy in the browser, importing a CA certificate, and all kinds of stuff. And we have not done that work for Google Chrome yet. But currently, the benchmarks do run in Google Chrome. So when running in a different browser, you just go Raptor test, --test. The name of the test is style bench. And we're just adding, hey, we want to run this in Chrome. And here's my local Chrome binary. Let's start that up. Again, we're just going to wait 30 seconds for the browser to set up. These tests are currently running on Central. You just go in the tree header, Mozilla Central, search for Raptor, and you'll see a section for Raptor, just RAP, and a section for Raptor running on Google Chrome, which is RAP-C. And you can check out all the results. Yeah, so it's just the same thing, but running in Google Chrome. The web extension is obviously it's the same source. There's only one browser extension that we use for both Firefox and Chrome. It was very similar, like the APIs are very similar. There's slight differences. For example, I can't remember which browser is which, but some of the APIs say you want to update the tab URL. Some APIs will return a promise, or one of the browsers returns a promise, and one of the browser does not. So some of the code is slightly different, but it's the same source, and it's probably like 95% the same code. And benchmark has finished. Chrome's going to shut down in a second. And there's our output for Perforator. And basically, in production, Perforator, the Perforator tool will grab this data and import it into Perforator. Okay, so that is it for my demo. Just stop sharing the screen here. Yeah, so that's it for me. I hope that was a I hope that was an interesting overview anyway. And feel free to check out the wiki and the source. I've put in the channel there. And yeah, if anyone has any questions, I can do my best.
Thanks, Rob. That was awesome. Has Raptor caught any regressions?
That is a really good question. I don't know the answer to that. I would have to ask our performance sheriff. It very well may have, and I'm just not aware of it. More than, oh, hang on a second. Wait a minute. I just realized we're on tier 2 right now in Central. Yeah, so no. Once we move up to tier 1, then we'll actually have performance sheriffing, I believe. So yeah, so to answer your question, no, not yet.
Okay, cool. Are the results published anywhere other than treeherder/perherder at this time? I was just wondering if maybe there could be a "Are we fast yet?" style, possibly oversimplified, just one number kind of easy to follow dashboard.
Yes, actually, Armin on our team is working on at least one dashboard that will be a better, easier place to go and check out some of these results. Because in the CI, like going to Perfer is really not the best way to look at results. It's more so we can do our automation performance regression and stuff.
Cool. The MITM proxy, I'm guessing that's man in the middle.
That's right.
Those archives, how do they get updated and how often?
That's a really good question. So they're updated. It takes it's a bit of a process. So basically, how they're updated is you have to have the tool installed. Part of Minim Proxy, they have a tool called Minim Dump. You turn on in Firefox, you tell it, I want to use a local proxy. You turn on a local proxy. You install the Minim Proxy tool and the CI certificate. And then with a command line in a terminal, you just start the recording. And then you just browse to whatever page you want to record. And yeah, so you wait. So it's a bit tricky. You can log in to sites and stuff. It can take a while because you want to make sure the page is fully loaded before you stop the recording. So yeah, you load the page, record it, you stop the recording tool, and then you repeat for each page in the set, and then basically we zip all of those up into one zip file, and that's on Tool. Now, I mentioned hero elements. Hero elements was kind of something that we wanted to try out and make sure that we can do it. And I'm not sure if we're going to actually go with hero elements down the road or not, but it's an option in case people deem it important to use that to measure specific elements in a page. But it's quite tricky. So what you have to do, you do the recording, and then if you want to add a hero element, you basically have to insert the hero element into the recording. So you run another script, and you basically have to tell it pass in what element you want to add a hero element to. Tarek wrote the script, which is awesome. So it takes a bit of effort to record the pages. Once you do it the first time, once you have everything set up and do it the first time, it's really not that hard. It just takes a bit of time. It just takes time. And then to answer your question, how often we record them, we update them. So TP6, so this technology, Minim Proxy, we have been using that on Talos already, and about a year ago we started that, and I just updated all the pages a couple of weeks ago. But I think there are plans to have these pages ideally updated like once a quarter or something like that. And again, it's going to depend how many we have.
Okay, cool. And I just have one more question. Because we have results for Chrome, what version of Chrome are we comparing nightly Firefox to nightly Chrome or a release Chrome?
So right now, we are running Chromium. We're grabbing that from Google's, I believe it's like their CI system, and that was the easiest way to get Chrome running in our CI, because we need to download it and install it and set it up. Eventually, what we're going to do is we will have a fetch task that will grab like the latest Chromium build, and then we'll use that.
Okay, cool. Well, thank you. I'll allow others to ask questions if they have any.
Just a quick question. I heard you're also working on the mobile part. So does it work through the web extensions of Firefox, or does it using some other ways?
Hey, Nozan, yeah, that's right. We are currently porting Raptor to work with GeckoView, and I I believe, I hope I'm correct, but I believe GeckoView does not officially support web extensions. However, yes, it's awesome. The GeckoView team has been helping us add, and they've been adding support for any APIs that are not yet working in GeckoView. So yes, so that we can run the Raptor web extension and have the same architecture. So yeah, so we're getting there. For example, GeckoView was not officially supporting browser tabs API, but the GeckoView team added support for that, which is awesome. So we're getting there. About some more work to go, but we're getting closer.
Okay, if there's no other questions, then we can finish up there. Thank you very much, Rob, for showing us Raptor, and the demo was awesome. If anybody wants to ask you any questions, I'm sure they can find you on IRC or Slack or in the phone book. Okay,
Thanks.
so look out for an invitation to next month's gathering. Otherwise, thank you everybody for coming along, and see you all again soon.
Thanks, guys.
Thanks, Dave. Thank you.